All right, good morning, everybody. My name is Wim DeCorte. I'm the Chief Technology Officer at Solion Consulting. And this is true. Models are dumb. They're dumb for the things that matter to you, basically all the knowledge, the data that's in your solution, and the business logic that you have embedded in your scripts in your FileMaker solution. So if you don't know why that is, or if you don't know how to not make it so, then you're in the right place for the next hour. Because I believe by the end of it, and that's my promise to you, you will feel better armed to understand what MCP is, why it matters, and also how it works. So let's dive right in. When you have workflows that you want to use AI for, at some point in that workflow, you'll want to give it access to your FileMaker solution. And not just the data in your FileMaker solution. I already mentioned it. You also want to give it access to the business logic, right? So the carefully crafted workflows that are embedded in your FileMaker solution through scripts. You want to give the AI application access to that too. So how do you do that? And to be clear, we are not going to talk about anything that originates from inside FileMaker, right? So we're not going to use these FileMaker AI script steps. We're talking about workflows that originate from outside FileMaker but need access to your FileMaker solution. And the problem, of course, isn't limited to AI applications having access to your FileMaker solution. It pretty much goes for any other system that you have that your AI application may want to have access to. It could be your help desk system or your accounting system, right? So it's whatever we're going to talk about today applies to all outside systems that you want to feed data into your AI application. And ideally, we want to do that in a way that isn't stupid, right? Because the way that AI applications were getting access to other systems, every AI provider was doing it their own way. ChatGPT had plugins, Claude had tools, Copilot had extensions, and at some point people say, well, let's not be stupid, let's create a standard, and that's how MCP came to be. Right? So we want to do it this way. For all things AI, one of the things that we pick up is a fear of missing out, but also a fear of joining in. And we see that both at the level of the developers and at the level of clients. We have a lot of clients that are really interested in AI, but they go like, well, what are the use cases? Like, what would I be using it for, right? So, and one of the best ways to get over that fear is to demystify how it all works so that it doesn't come across as this magical black box, right? So we'll be spending a lot of time on that today by looking at how it works, right? And more than that, we will also spend some time looking at what makes it a success or a failure. Once you set out to use and build AI applications or AI-driven workflows, what is it that will determine the success or the failure of that? So we'll spend some time on that. Okay, so MCP, Model Context Protocol. Before we get there, I want to go back to the basics a little bit and talk about this, right? So this is the diagram that I'll be using for an AI application. In this case, it's one that you're all intimately familiar with. Anybody who's used ChatGPT will recognize what this does, right? So the input, the trigger, if you will, is somebody typing in a message, or like what Todd was doing yesterday, speaking a message. That's your input, right? That's what gets fed to the AI application. The AI application has access to a model. In this case, it's a text generation model. And it's really the model there that is the single most important aspect of that, right? So the quality of the model will determine the quality of the output. We'll expand that AI application to something like this, right? Pretty much all AI applications today have a built-in MCP client, meaning they understand the protocol, they know how to speak the protocol, if you will, speak the language, to talk to an MCP server, and it's at the MCP server level that you hook up your FileMaker solution. So that's where we will end up. And I want to emphasize that not all AI applications are of the chat nature, right? Like a lot of the demos that we see are using Claude or using chat applications, and that's really because it's so easy to understand and wrap your brain around and easy to demo. But this isn't another AI application, right? In this case, the trigger isn't somebody typing in a text or a question. It's an email coming into a particular mailbox, right? So say that it's the sales mailbox for a company. What we want to do there is we want to scrutinize that email, do a sentiment analysis on it. and that's some AI-driven. There's models that are really good at sentiment analysis. If we determine based on that that it's a complaint, that it's a negative email, right? We want to feed it to another AI application and take some action, right? Maybe we want to go look up who that client is in our FileMaker system, look at the most recent orders, craft a friendly email back to the client, but also escalate it through a Slack channel so that somebody can pay attention to that email and so that it gets a higher priority, right? So this is an AI application that is not of the chatty nature, that happens completely headless, if you will, in the background. All right, so models, because they are so crucial to how the AI application works. Trying to find the best way to describe what a model is. In essence, it's a lot of high-level math, right? That's really the foundation of what a model does. So it can take an input, could be text, like an email or somebody typing in something, could be an image, and then the model will detect patterns. And it does that in a very complicated way through different layers. And fundamentally, it predicts what the outcome should be, right? And we'll come back to that because it guesses, in essence, right? Like it takes a best swing at what the outcome, what it thinks the outcome should be. So keep that in mind. And then it basically will generate an output. Fundamentally, a model is really just nothing more than a lot of numbers. And I mean a lot of numbers, billions, right? They call them parameters, but in essence, it's a lot of numbers that are stored in files. And then it comes with rules on how to use the model. If you've never looked at a model, when you download a model, this is what it looks like, right? It's just a bunch of files. The first top section there, these are the big files. That's where the numbers are stored. These are like 5 gig files, a couple of those. And this is not even a hugely complex model. And then at the bottom, there's a bunch of JSON files and whatnot that encapsulate the rules of how the model works, right? So a model in and by itself is stateless, right? It has no conscience, it has no awareness. You need an AI model server to host this model so that the AI model server can read these instructions and know how to interact with the model, give it the input that it requires, and get the output out of that, right? So this is what a model looks like. Nothing too fancy there. So when you see a diagram like this, where you have an AI application and it has access to a model, that's actually shorthand for this, right? It's really the AI model server that the AI application has access to, and it's at the AI model server level that the model lives and basically gets access to. And getting access from the AI application to your model server, that's just a URL, right? I'll come back to that. Every AI integration looks very much like an API integration. If you've ever done an API integration, you'll recognize a lot of this. Speaking to an AI model server where the model lives, that's exactly like an API. I'll leave it at that here for the basics of what a model is. But if you feel like you don't know how it works, or it still feels like a little bit of magic, and you want to learn more about the basics, I did a week-long with Richard Carlton's FM training video, so we covered a lot of these basics. So you can find those and have a look at those. Todd Geis did another week-long session with FileMaker training there on Richard Carlton. So between those two, there's a lot of solid material that you can look at and figure out how it all works. All right, so I said that models are dumb, right? So, and this is one of the main reasons. And you can ask any model for what its training cutoff date is. In this case, for context, what we're looking at here is a LibreChat, which is a self-hosted chat experience or chat client. You'll see in the top left corner where it says GPT OSS 20 billion parameters. So that's the open source OpenAI model. So self-hosted again, right? So nothing, because I want my conversations to be private, so nothing goes out from here to the internet. So if I use that model, it tells me that it is trained with data up to just about over a year ago, right? So it doesn't know anything that happened since, in this case, June 2024. So that's one reason that models are dumb. The other one is that their knowledge is limited by scope. And it's a huge scope, so don't get me wrong, it's not a very small scope, but still, it is limited in scope of what its knowledge is. And if you ask it, it'll tell you what it's not, right? It cannot give you real-time data, and it doesn't know anything about proprietary systems, like our FileMaker systems. Right? So a model, by definition, doesn't know these things and cannot give you answers. So if you ask it answers, or if you ask it questions like this, it doesn't know what to do with that. Right? A model cannot answer these questions. I may be going like, that's not entirely true. I've done ChatGPT, and it can tell me what the weather is somewhere. That's not the model doing it. That's because the chat client, like ChatGPT, already has access to tools that can supplement what the model knows by going out and figuring out, making a web call to some weather API and figuring out what the weather is. But the model, in essence, cannot answer these questions. And that's fairly fundamental. So it begs the question, what do you do with that? Like, how do you make it so that your AI application does have access to your data and your business logic, right? One way of doing that is called fine-tuning. What you're doing with fine-tuning is, in essence, you're replacing the model that you had in your AI application with a variation of that model that is trained on your own data. Right? So that's what you're doing. You're basically replacing the model with another one. And training is the process of adjusting those billions of numbers, changing their values so that basically your data from your system is now embedded in those numbers, that those numbers, those billions of parameters reflect your data. And it's a very tedious process, right? So because it has billions of parameters, you change a few million at the same time, then you run some tests to see how accurate it is, and you repeat that. So there's usually trillions of calculations involved in fine-tuning a model. And it's fair to say, tuning a model isn't a developer process, right? It's more of a data science process. So it's fair to say that not many of us are going to be fine-tuning our own models. So, and also keep in mind that when you train or fine-tune a model, you do it in a point in time, right? So you only feed it the data that is known up to your fine-tuning moment, to your training moment. So anything that happens after that is not possible. So it's these same questions. When you ask them of a fine-tuned model, it still cannot generate those answers for you. Right? Because if you have open invoices, when you train or fine-tune the model and you give it a list of open invoices, it's the open invoices at that time. Like if an invoice gets closed or you generate a new invoice, 5 minutes later, the model doesn't know, right? So it's not a real-time process. It's still a very static point in time. So keep that in mind. Now, fine-tuning does make a lot of sense if you have static information, right? Like a lot of medical information, for instance. And there are fine-tuned models that start with a base model, but then are trained on a particular domain of information. As long as the information is static, then fine-tuning is one way that you can go. A second way that you can feed data into the AI application is to use RAG, or Retrieval Augmented Generation. And there was a session, I believe, yesterday on RAG. The Claris AI Model Server supports RAG, so it actually supports fine-tuning as well. But RAG is included in the Claris AI Model Server, so you can do that. What really happens when you do RAG is something like this, right? So on the right-hand side, we still have our AI application as we had, and we're back to the chat example there. But our AI application now also has access to query data that you stored in a separate database, because that's really what happens when you use RAG, right? You build a separate database, you extract data from your FileMaker system, you embed it, that's the embedding model there at the bottom. You embed that data and you store it in a separate database so that your AI application can take the question, embed it in the same way, and figure out by looking at the stored embedded data that you fed it, whether there's an answer there based on the data, right? So a couple of key points. You're extracting data from your FileMaker system to feed it to the RAG database, right? So that's sort of what that looks like. Now, it's slightly more real-time than fine-tuning a model, because fine-tuning a model takes so much time. In this case, when you use RAG, You can have some sort of triggers in your database where you basically spit it out as PDF or as JSON or as text, and then you feed it to your RAG database. But it's not exactly real time, right? Like the query tool, your AI application, isn't connecting to your FileMaker system. It's connecting to the RAG database. So whatever time delay you have between extracting from your FileMaker system and feeding it to the RAG database, that is going to be your not real-time aspect of it. Right? So it's not a live connection. So back to these questions, right? So fundamentally, the answer to these questions is still like can't be done. Right? You can feed the current weather information in the RAG database, but it's again static, point in time. It's not real time. Same with your invoices. In addition, you can feed a lot of data into a RAG database, and that'll be your data. And now the AI application will have access to it, but it has no access to your business logic, right? So it cannot be part of a workflow that needs to do something. So that's another thing to keep in mind. So that's how we end up with tool calling and MCP. So our AI application, and by now, and the AI application, by the way, most AI applications are written in JavaScript or Python, right? You can write them really in any language, but a lot of them are JavaScript and Python. So realizing that, you can go, well, if it's just JavaScript or Python, I can make an API call to my FileMaker database, right? We've been doing that all along with other API integrations. And the answer is yes, you can. But that would make it a fairly tight coupling between the AI application and your FileMaker system, right? Because you'd have to write code at the AI application level to make that connection, those API calls to your FileMaker system. Can be done, right? That's absolutely one way to go. And it sort of assumes that you have access to the code base for the AI application, right? If it's ChatGPT or Claude, you wouldn't be able to do that. It's a closed source thing, right? But you could if you wanted to. So tool calling in MCP is really all about making sure that you have direct and real-time access to other systems, right? The things that fine-tuning and RAG didn't give us, that direct connection and the real-time aspect, that's what tool calling in MCP is going to solve for us, right? So having that direct access. And that's how MCP was born. That's the official MCP logo and the official MCP infograph there. On the left-hand side, we basically have a bunch of different AI applications. On the right-hand side, actually I should turn that around, I guess. We have different systems, right? And that's really all that it is. The AI applications all speak the same language. They all use the same protocol to talk to an MCP server. At that point, they don't care what happens, because they just talk to the MCP server. The MCP server can connect to the back-end systems, whatever that system may be, in any shape, way, or form that it chooses, right? So that's really the promise of MCP. And that's how we get here, right? Most AI applications have that built-in MCP client, so they know how to speak the language. So really all we need is an MCP server that we can hook our FileMaker system up to, and we're set. Claris has an MCP server. You saw that one yesterday. If you really want to, you can create your own, right? Because it's a standard. There are SDKs for that. You can download those from Antwerp and write an MCP server in any code base that you want. It's something that's open to you. All right. So that same screenshot that I showed you of my LibreChat with my open source OpenAI model, if I wanted to have that chat be connected to my FileMaker system, in a nutshell, how would I do that? And this is the Claris AI model server. When you set it up, when you make a connection to one of your FileMaker servers and one of your files, there's two pieces there that you can extract from that. One is the URL. Remember, most of these things look very, very similar to API integrations, and that's exactly what it looks like, right? So your MCP server is just another URL. So you copy the URL, you copy the header, that's the authorization. I added to my, it's a little small, I apologize, but this is the LibreChat configuration file. So I basically just declare an MCP server there at the bottom. I give it the URL to where the Claris AI server is and how to authorize it, basically how to access it. And if I go back to my LibreChat chat experience, there is an MCP servers button. That's what I meant with pretty much all AI applications these days have built-in support for MCP, right? They have built-in MCP clients. And that's really as simple as it gets, right? From my chat experience, I can now pick that MCP server that is my FileMaker solution or that is hooked up to my FileMaker solution and connect to it. That's, in a nutshell, that's how simple it has become to have an AI application talk to my FileMaker system. So if I boil it down to how it works, AI applications have built-in MCP clients. They speak to the MCP server using the MCP protocol, right? Fundamentally, that's what it is. It's just a way of talking. Now, the MCP server connects to the FileMaker server to the data API and OData API. And the reason why it makes a lot of sense when we get a little further, if I wanted to, I could use ODBC or JDBC there, right? Because again, the AI application doesn't care how we do it. It all happens at the MCP server level. The AI application is just going to talk MCP to the MCP server. The MCP server will make the actual connection to my FileMaker system. So any API that FileMaker server has is fair game. Now, I wouldn't use ODBC or JDBC because you cannot run scripts through that, right? So that's the main reason that I would use the data API and OData API. It's also what the Claris MCP server uses under the hood there. So when we ask those questions and we have it all hooked up correctly through MCP servers, now I can answer these questions, right? You can have a tool that figures out what today is or what the weather is in Antwerp today. When I hook it up to my FileMaker solution, I can get a list of my open invoices. And up to this point, we've been talking mainly about data, although I've mentioned a few times that the business logic aspect, right? So where the AI application can have access to your business logic that you have already created in your FileMaker solutions, we can do that too, right? So we can have something like this, where I have a tool that under the right circumstances, I can make my AI application approve an invoice, right? Or create a work order, or do things that will change or generate data in my FileMaker system. So how does that work, right? Same schematic there. AI application talks to the MCP server. And because we're using data API and OData API, at the MCP server level, right, I can create tools, because that's where you create tools. That's where you define tools, right? You give the tool a meaningful name so that your AI application knows that if the user is asking about finding an invoice or approving an invoice, then the name of the tool, the description of the tool will reflect the tool that it should pick to do the job. And you basically just hook up those tools to scripts that already exist in your FileMaker solution, right? Because the OData API can run scripts. And that's really how it's done. And that's how you can expose your business logic that you have already created or that you create specifically for this purpose in your FileMaker solution to, in essence, your AI application. All right, so from this point forward, we'll talk about a little deeper about the technical stuff on how it all works, and then we'll talk about the things that really matter, right? As I mentioned in the beginning, the things that will make or break when you set out to build an AI application like that. Before we get there, I want to mention this a little bit, right? So this is the Gartner hype curve. MCP is about a year old. It was born November last year. And for the first couple of months, nobody paid any attention to that, right? Because the landscape at the time was that every single provider was trying to come up with their own way of doing something like tool calling, the stuff that we're talking about. So Anthropic postulated MCP as a protocol. And like I said, for a couple of months, nobody really cared. Everybody was doing their own thing. And when we were all together in EngageU in the US, back in March, OpenAI announced that they wouldn't stop doing their own effort and that they would adopt Anthropic's effort, which was a major breakthrough, right? Because now we don't have different AI providers each fighting for dominance, if you will, about their approach. OpenAI said, we're done doing our own thing, we're going to do what Anthropic does. That's when that was the technology trigger as we see there, right? At that point, MCP took off. Because now we have a standard. We have two of the big providers, and really everybody else followed suit soon after. So MCP is in adoption is just about 9 months old, right? So that's how young this all is. So we're very much in this first part of the curve here where everybody's trying to figure out, like, okay, how does it work? Why should I care? At some point, there'll be some disappointment when people go, it's not quite what I expected, but that's going to level out, and we will see solid adoption of that, mainly because it's a standard and it actually works really, really well. All right, so this is the more complex AI application that I mentioned before. So where does MCP fit in, MCP model context protocol, right? So we already talked about the model and how important the model is, because fundamentally, it's the model that will generate whatever the outcome is, whatever the response is to your question, to whatever it may be. That's the model's job. And we already know that MCP fundamentally is a protocol, right? It's a way of talking between the AI application and the MCP server, so that the MCP server can talk to your FileMaker stuff. So where does the word context come into play? Right, so model protocol, we're fine with that. Context refers to providing the AI application with everything that it needs to know. The whole conversation that the user may have had up to this point, or in our case, the email, and perhaps the whole conversation by email that was coming in, right? So it's providing all the contextual, hence the term context, the contextual information that the AI application needs to generate a response. And that now includes having a list of capabilities, right? A list of tools that has been exposed by the MCP server to the AI application, right? So the tools, the list of tools, become part of the context, the thing that the AI application needs to know. And there's a couple of different contexts. I'm not going to spend too much time on that one because it's really all about tools these days. But MCP as a protocol, as a standard, allows for 3 types of context: resources, tools, and prompts. We will be talking about prompts to some extent. If you want an analogy for this, if my AI application was a pizza joint, then the resources would be the menu. Right? What pizzas could I have? The tools would be something like ordering a pizza, right? And the prompts would be, I want my pizza to be well baked, right? Or I want to have extra cheese, or leave it by the doorstep, right? So think of it in this way. Each of these contexts serves a different purpose, but for today's presentation, we're really talking about tools. The resources and prompts haven't been universally implemented by all the AI applications, right? So mainly because it's still a very young standard, but the tools is what we're talking about. So the protocol itself, it has 2 variants. I can spend a lot of time on this or not a lot of time on that. I'll just hint on that. If you want to have me expand on that, just yell out or come see me afterwards. I want to drive home the point with the next couple of slides that it's not really magic. It really looks like any API integration that you've ever done, right? So there's 3 ways that an MCP server or an MCP client can talk to an MCP server, well, that's exactly what it is, how the AI application can talk to an MCP server. I'm only going to talk about 2. One is SSE, or server-side events. That's how the Claris MCP server currently works, although it's building support for the second one. What that looks like is really when the AI application makes its first connection to the MCP server, it's really just like that. If you've ever done an API integration, you go like, yeah, I know exactly what that looks like. And then the MCP server will respond with a proper HTTP response and say, yep, you're connected to me. And it's at the bottom there, it says, communicate to me over that messages endpoint. So when the AI application now says, okay, let's shake hands, because that's really what the initialize is all about, then the AI application will take that endpoint that was given to it by the MCP server and make a call. It's a little small, I get it. We will make a call to that endpoint to say, here's the version of the protocol that I support, and any other information that we need, and the MCP server will respond with, again, an HTTP response, and then its own version of the handshake to say, yep, we agree on the version of the protocol that we support, we're good to go. Next up, really what the AI application would do is ask the MCP server for a list of the tools, right? What capabilities can you give me? And the MCP server will again respond, just like any API would respond, and will give a list of tools that we have. All right, and it uses JSON RPC as the format. Fundamentally, it's just JSON. Right? Again, if you've done API integrations, you'll recognize a lot of this stuff. So that's how the AI application and the MCP server communicate with each other under the hood. It's really nothing more complex than this, right? Just like any API. I know that I'm repeating that ad nauseum, but one of the tools in this case would be get weather, right? So that's a capability that the MCP server exposes to that. At some points, the AI application, based on the user's input or where it is in its workflow, will decide, I need to call that tool, and that's what that looks like, right? So the method is now tools call, and it will give the name of the tool based on the list of tools that the MCP server had given it, right? So, and then we'll receive a response from the MCP server after the MCP server has done its thing. The second variant, so what we've covered was SSE, or server-side events. Really, what happens there is the MCP server and the AI MCP client, or the AI application, communicate on two different channels. They communicate through a sort of like persistent connection, and then more like an API call connection. Because of that sort of like built-in inefficiency, people are moving away from that and going to a streamable HTTP variant of that. It's really just the same thing, but now everything is running on a single channel, like what we're used to if we do API integrations. So I can show you how that works, but fundamentally it's the same thing. So hopefully with that, we sort of demystifies that protocol, right? How does an AI application talk to an MCP server? It's really just like an API, right? They exchange a bunch of calls, they exchange a bunch of JSON. That's really how they do it. All right, so the bigger question is, we have tools, we define tools at the MCP server level. Where do those tools get executed? Like, what executes those things? And you may think it's the AI application that executes the tools, and it really isn't, right? All the executions of the things happen at the MCP server. All that the AI application does is get a list of tools that it can call, and it can make a decision to call a tool. When it calls a tool, it just tells the MCP server, execute this tool for me, give me the results, right? So the AI application makes no connections to our FileMaker database at all. Everything happens at the MCP server level. That's where the tools gets executed. And it's sort of important, so hold on to that thought, because it gets into a gotcha that we will cover later that can sort of make or break your implementation of this, and that really speaks to how will the model, or the AI application by way of the model, how it will determine what tool to call, right? Again, I mentioned this, models are just, they are probabilistic, right? They guess at what should be done. And that includes tool calling, right? So they'll guess at which tool to call. So keep that in mind, because that's important to make sure that we get this right. There is some confusion around MCP and agentic AI. There's a lot of talk about agentic AI as if it's the best thing that everybody needs to achieve. I'm here to tell you that it doesn't need to be, although I definitely can talk to the power of agentic AI. So there's a whole spectrum of AI-driven workflows, right? So it flows from the simple, like the more workflow automation that is more like a flow chart, right? Like, if this happens, then do this, or if this doesn't happen, then do the other thing. And you sort of like build your workflow through that, very much like a flow chart. Whereas agentic AI is a lot more complex, where the agents can do their own reasoning, do their own planning, their own decision making. It goes sort of like this, right? If I go to IKEA and I buy a kitchen, it comes with a manual, right? So if I follow the manual, and the manual will tell me when to pick up certain tools, right, along the way. If I don't hallucinate along the way and I follow the instructions, I will end up with a functional kitchen, right? But it's a very linear process to do that, right? It could be a complicated process because I'm not a very good handyman, but it's still a very linear process. An agentic AI would be something more like this, right? And there's a reason I got 3 little dudes in there, right? Because one could be a plumber, one could be an electrician, one could be an architect. They each have their specialized roles, and if I leave them be, that's almost like me hiring a contractor to build me a kitchen instead of me doing it myself, right? That's sort of like what it is. So if I leave that team to their own devices, they will figure out how to design a kitchen, build a kitchen, install the kitchen, and they'll do that on their own. Right? So any of these 3 dudes there is an agent, and an agent can call tools as many times as it wants to get the job done. Right? If you were in Todd Geist's presentation yesterday, he touched on that a little bit, where an agent will call tools in a loop until it's done. Right? The interesting part there, and it's a little bit of a mind bender, the definition of done is very often set by one of the other agents, not by the user, not by me, right? So that's something to keep in mind. So the workflows give you a lot more predictability. What you sacrifice is autonomy. Right? The agents or the workflow is a lot more restrictive in what it can do and what it cannot do. When you go full agentic AI, you basically have a lot more autonomy, but you sacrifice a little bit in predictability, right? So the guessing aspect becomes a more important thing in agentic AI, right? And with that comes the responsibility of the developer to make sure that you're herding your cats. All right, so let's move on to the stuff that you really need to know and that can make and break your solution a little bit. I touched on that a few times already, right? For me, and Todd Geist made a point yesterday as well, when it comes to your FileMaker solution and giving an AI application access to your FileMaker solution, we're talking mainly about giving access to your business logic, right? And business logic in FileMaker terms are scripts, right? That's how we construct our business logic or encapsulate our business logic into a FileMaker solution. And I think it's a bit of an opinion, but hear me out, and it's important to think about. To me, it's more important to give AI applications access to scripts than it is to give them direct access to data, all right? I'll let that sink in a little bit, but here's an example, right? If we have a system that has invoices, think of the invoices in the FileMaker system as an entity, right? Because an invoice, of course, it will have an invoice table, it will have invoice line item table. There's probably some links to a product table, a client table, and a pricing table in there, right? So an invoice is really the cross-section of at least 4 or 5 tables there, right? So do I want to give access or do I want to rely on the AI application having direct access to these 5 tables to make sure that it creates or modifies an invoice correctly? Or do I just want to call a script that does it for me, right? Where I am in full control over what happens to that invoice. So for me, that is why giving access to business logic is more important than giving access to data. I'm not being dogmatic about this, right? I'm not saying like never give it access to your data. There's going to be use cases where it makes total sense to give it access to your data, but I'll probably lean towards giving access to scripts more than data at any given time. And this is not FileMaker specific, right? Like if you ever integrate it with, say, an accounting system, they very rarely give you access to their core tables, right? They make you go to staging tables or you have to feed it to their version of scripts, and they'll figure out what to do and where to put the data, right? So, so keep that model in mind as you work through that. The other thing, we mentioned this a few times already, is models are just guessing, right? So the fact that you have tools, that you've defined tools at the MCP server level, and that you've exposed those tools by letting the AI application call for a list of tools, that doesn't guarantee that these tools will be used, right? Or that even the right tool will be used. It's just guessing. which brings up the question, how do we make it so that the model will pick the right tool for the job? And that comes down to what's called prompt engineering or instruction writing. There's different terms that really mean the same thing, right? You as a developer are responsible for writing the right instructions. These instructions become part of that context, right? The C in MCP, right? The thing that the AI application needs to know about the capabilities, that includes your instructions so that you increase the likelihood that the model figures out when to call a tool and then call the right tool and give the tool the right information, right? So they're really, think of them as templates to make sure that the right thing happens at the right time. And that is something that is under your control. There's some best practice around that. And if you look at this list here, you'll note one thing, right? It's all about being very explicit. Right? The worst thing you can do with your prompts and instruction writing is leave things very implicit, where you sort of like hope that the model will get things right. So don't do that, right? Be extremely explicit about the things that it should do, the rules that it has to follow, all of these things. There's a couple of places where you write those instructions. We touched on that a little bit yesterday. This is a screenshot from the Claris MCP server where you edit a tool. So the tool name and the tool description are your two main places up front where you have to be very clear, right? So give your tool a meaningful name and give it a meaningful description on what you need to do. The second place is in the input schema, right? Where you define what the model needs to give to the tool before it can run the tool, right? So any parameters for your scripts or stuff like that. But just the description of the parameters will help the model pick the right tool for the job. I'm not going to spend too much time on this, but there are different places in an AI application where you can write those prompts or leave those prompts or put those instructions, right? I just mentioned one of them that is in the tool definition, if you will, right? The tool name, the tool description, the input schema. And again, this is all fairly fresh, so don't take those as absolute numbers. These are just based on best practices over the last 9 months, if you will, right? But you'll get most of the success by being really good at describing the tools, right? So that's where you should spend most of your energy. At the server level, the MCP server itself can have its own instructions that basically go for all of the tools that the MCP server has. Your AI application can also have its own set of instructions, right? And these instructions, again, become part of the contextual information that the AI application has to figure out, together with the question that's being asked or the email that comes in and the content of that email. So all of that together is then evaluated by the model to go like, what do I do with this, right? Like, what do I do with this information? How do I take a guess at what I should be doing with that? So, so this is a rough distribution there of where you would put those instructions and what to do with that. Having played with this a fair bit, this is where you'll spend a lot of time. Right? You will not spend a lot of time defining tools or writing your scripts. You probably already have your FileMaker scripts for this. But to make sure that your AI application functions exactly like you want it to be, you'll be spending a lot of time here. Right? So be ready for that. This is a very iterative process where you write it all up, and then you do as many tests as you can get away with, and then you look at the results and go like, how accurate and repeated accuracy do I get from this? And then you tweak your descriptions and your prompts, right? So, but be ready to spend some significant time on this one. It's a little small, but you'll have it in the slides there. This is a bit of a template that you can use for a tool description, right? Where you describe things that it should do, things that it should never do. If there's a bit of a decision tree as part of when to call this tool or not to call this tool, include that, right? So models do really well when you repeat stuff in your description, right? So be verbose is really the message here. It also works really well when you have bullets and numbered lists in your description. So this is one template that you can follow. This is my MCP server. What I really wanted to set the stage a little bit for what I'm going to show next. This is an MCP server. This is the Claris MCP server. I really only have 2 tools here, and as you can see, they're scripts only. I don't have any tools on the table definitions, mainly because of my opinion that I want to channel everything to the scripts when I can. So 2 tools. One is to get the DDL from the solution, basically the table description, the field descriptions. And the other one is to run a script that does a natural language query. It's not terribly important what those two tools do, but I just want to mention that we have two. And this is then it's going to be a little small, but then this is the description for that first tool to get the DDL from my solution. Right? And as you can see, it's pretty verbose. It's even more verbose for the natural language query script that I have in the tool. Right? So when I say be verbose, I wasn't kidding. Right? Like, spend a lot of time on those descriptions. When you bring up the MCP server, doesn't really matter which server it is, there's typically like a somewhat bigger field for your description. Don't be fooled by the size of that. You'll be spending or putting a lot of text in there way beyond just what's visible on the screen there size-wise, right? So I can't stress this enough, right? So this makes or breaks to a large extent how accurate the AI application is going to be in picking the right tool for the right, at the right moments. All right, so if we play the tape forwards, now we've put in a lot of work to make sure that the AI application can pick the right tool. What does it do with the stuff that you bring back, right? Like, if I have a script that will find say the open invoices, right? So that's a bunch of data. I want to make sure that the data is presented to the user, if it's a chat experience, in the right fashion, right? That too is something that you'll need to describe. You'll have to tell the AI application what to do with that. You don't want it to be guessing at something, right? You don't want it to create a pie chart if you want to have a table view, right? So that too is something that you'll have to describe. And there's a couple of different ways that you can do that, right? So again, in the description, I'll show you an example in a bit. Some MCP servers also have a place where you can explicitly describe an output schema, right? Because we've already talked about the input schema, the parameters that you want to pass into your tool. Some MCP servers have the ability for you to describe an output schema. You can also do that at the AI application level, right? You can create a prompt or an instruction that sits there that basically as long as it's specific to your AI application, you can say, whenever you receive invoice data, always use a table view. Right? I'm making a simplistic example there. Or you can put it in the result itself, and I'll show you an example. So this is, was there a question? No. So this is the description for the getDDL tool, and as you can see there, there's a section in there on what to do with the results. Right? So that's one place where you can describe to the AI application, when you get something from this tool, do this with that, right? So that's one place that you can do it. Another way that you can do that, one that I've been playing with a lot is, again, most tools in my world are going to be scripts that I call, right? Scripts have an exit script where you basically pass out of the script whatever the script was doing for you. If it was finding invoices, it's going to be JSON or CSV or whatever format that I choose to pass that list of invoices back to the AI application. And you can create a format like this where you basically package the data that you're sending in, but you can also include information on what to do with that. In my case, I'm saying like visualize this in that way. Right? So that's another way that you can do it. And I like this one because it keeps that inside my FileMaker scripts. Right? I don't need to go to the MCP server and change a bunch of prompts there. As a FileMaker developer, I can do it all from here. All right. What MCP is really, really good at, right? Let me take a half step back. What models are really, really good at is finding patterns in data, right? They do this high-level math. They can look at a bunch of data at the same time and figure out patterns that we as humans would find very, very difficult, or it would be very time-consuming for us to find these patterns. They can do it really quick, and then they can do it really well. If we extend that to MCP servers a little bit, then MCP really shines by collecting data from different systems and bringing all that data into the AI application, so that the AI application can look at data from different data sources at the same time, right? So that's really what MCP servers is really good about. Now imprint this a little bit, right? Look at this. You may go like, because I have 3 MCP servers, right? One for FileMaker, one for my accounting system, one for my help desk system. So why would I do this and not that? It's an important question. And it really comes down to this, right? Every MCP server that you have, and I mentioned this, it's at the MCP server level that you define your tools, right? So if I follow this model, then my MCP server would have all of these tools on the right-hand side. So that's, I don't know, about 12, 15 tools that would all flow to the AI application through a single MCP server. That's a fairly long list of tools. The longer your list of tools, the more confused the AI application can get about which tool to call under what circumstances, right? That's why in my previous slide, I had different MCP servers. So you would create an MCP server for each, let's call it functional domain. Each MCP server has just a limited number of tools. That increases the chances that the AI application will talk to the right MCP server and pick the right tool under the right circumstances. That's a really important lesson to learn there. A few more gotchas that we talked about. I mentioned this a little bit in the beginning, but I don't want to gloss over the point, right? So your data and intellectual property. When you use a commercial AI provider, you're sending your data or your intellectual property, like the schema of your solution, how your solution is built, right? Like if you're not sending a data, but you let the model generate and execute SQL query or SQL syntax, you got to tell it how your solution is built. It's got to understand your tables and fields and whatnot, right? So it's not always the data. Sometimes it's your IP that you're sending, but you're sending it, right? You're giving it away, in essence, right? That becomes a trust thing, right? Do I trust Anthropic? Do I trust OpenAI? Do I trust Cohere? I cannot make that decision for you, but for me, that's a really important question. For my client, it's a conversation that we have with our clients, and Sarah here will talk about ethical AI right after this one. It's a really important conversation to have, right? So we should not be blind that we're doing this, right? So once we hook up our FileMaker system to an AI application, you got to think about that AI application, right? Where does that live? Where's my model? Now, MCP servers don't really hold on to any data, right? They're just traffic ops, but data flows through that, right? So there too, you have to decide: do I trust the provider of the MCP server, because there is data flowing through them as sort of like the proxy between the AI application and your solution. Where you covered number of tools, right? You want to be careful not exposing too many tools through a single MCP server, and potentially think about splitting these MCP servers up by the functional domain stuff that I talked about. Let's talk about performance a little bit. There's 2 aspects to it. One, we now all realize that in the back end, we're talking through the data API, OData API. So we're going to get the performance out of that as it is, right? Again, the design of your solution is going to be a big, big factor in how performance those data and OData API calls are going to be. But in general, anything you do or you want to expose to MCP tools isn't for the kind of stuff where you want sub-second responses, right? That's not what MCP servers are about. If you need high performance responses, then you may want to go back to something we touched on directly, where in your own AI application, you make direct API calls right from the AI application and not go through an MCP server, right? Because the MCP is a proxy, right? It'll receive it, then it'll make its own calls, and then it'll respond back, right? So you'll get really good performance. I'm not saying here that MCP is horribly slow. It is not, right? But it is something to consider when you want or set out to build an AI application that needs to have that sub-second response stuff, right? So it really excels at complex multi-step processes where even a few seconds of latency is totally acceptable, right? So that's something to keep in mind when you think about performance. We talked about context, right? All the information, the email, the chats, the instructions that we wrote, the tools, the list of tools, the description of all of tools, all of that goes into the context at the AI application, and specifically for the model. And it could be that you're crowding that context, right? What I mean by that is, and this is a screenshot from LM Studio, which is a free AI model server. Every model has a context length, a maximum context length. And typically, an AI model server it also has a setting where you can set up to the maximum that the model allows, where you can set the length of the context. In this case, we're talking about 130,000 tokens. If your context, everything that you try and feed into your AI application exceeds that, that's when the model will start to forget things, right? If you've ever done vibe coding, like an extensive vibe coding session, you'll get to invariably you get to that point where the model will start repeating mistakes, where you go like, but we already talked about this, right? Like, why are you doing the same thing again? That's that, right? It got to the end of its memory, if you will, basically erased some older parts of its memory, and that's how that happens. So that's the concept of context crowding there. So that's something to keep in mind. It's kind of contradictory to what I was saying. I told you to be very verbose in your instruction writing, right? Because that maximizes the chances that the AI application will get it right. The penalty for that is that you're using up a lot of context, right? So it's another aspect of why you will find yourself spending a lot of time in that description writing and getting it just right, and finding that balance between being very verbose and accurate in your descriptions and your prompting, while still working within the context of your model and your AI model server. So something to keep in mind. All right, and this is my last slide here, and then hopefully we'll still have a couple of minutes for Q&A if you want to. In all things, when it comes to building AI workflows and hooking those up to our FileMaker systems, there's a couple of different skills that we found that we didn't realize that we needed to develop, right? I just want to cover those quickly. The first one is those deployment options, right? Those conversations with clients about data privacy, intellectual privacy, like we can use commercial providers, we can deploy the AI model server locally, we can deploy the MCP server locally. Do we trust something like AWS Bedrock versus the commercial providers, right? So we have to understand what our options are, and we have to know how to deploy that, right? What does it mean if you deploy everything locally? What does that look like, right? Do we understand where to find an AI model server, or like Claris has one, like what kind of machine do you deploy that on? Like how do you pick the resources for that? So that's the first skill. The second one, and it's a big one, is data readiness, right? If you're now exposing your FileMaker data to an AI application and we want to have the best accurate results, your data has to be in a consistent shape. A lot of FileMaker systems don't have that level of data cleanliness, if you will, right? So, and it's not just a FileMaker thing. We've done a couple of big Salesforce projects where we spend a lot of time cleaning up data before we can get accurate results through AI. So keep that in mind. And then, of course, there's the whole theme of how do you verify that what the AI spits out, what the AI gives you, whether that's even accurate, right? And does it stay accurate over time? So what is a good framework for testing that and making sure that you have the confidence that the AI application does what you think it does? We covered this one. You will spend a lot of time with this one. Instruction writing, right? Getting it right, finding the right pattern, the right level of redundancy, the right level of verbosity as well to stay within that context. So these are the 4 skills that we identified that we have to train ourselves on and train our developers on to make sure that we're in the best possible shape to build successful AI applications. And that's it. Ask me anything.
Does the FileMaker AI now have MCP that will work with the new Claris MCP server?
The short answer is yes. The Claris has an MCP server that is currently in ETS, right? So if you want to play with the MCP server, reach out to the people at Claris, and you can start playing with that. On the FileMaker side, there's almost nothing you need to do for that, right? Because it just uses the OData and Data API. So any FileMaker server is ready to be used in an MCP context, right? You just need the MCP server to make that connection. The FileMaker AI, so the script steps, the FileMaker script steps? Yep, all right, I get the question. So you're talking about the Claris AI model server. That's the piece that hosts the model, right? That is actually totally independent of MCP, right? So your AI application needs access to a model hosted on an AI model server. So the Claris AI model server does that just fine. Your AI application also needs access to an MCP server, which are two different things, right? So one is not dependent on the other.
I have just a comment, and I'm interested in your take on that. Your IKEA idea of building a stringent pathway to your kitchen, or have 3 people discuss it and build their own path to it, was very powerful as a picture. And I think that we all have to envision that when we are deploying those AI models, we are somehow having those 3 people build or discuss the same kitchen over and over again for something that we mostly have done in our scripts already. So not everything needs to be solved by AI. And
I couldn't agree more. Fundamentally, the main thing to remember is that if we give something to AI, it's going to take a guess at it, right? The probabilistic nature of AI is very, very real. Versus a lot of the stuff that we do today is deterministic, right? When we write a script, we execute the script is going to do exactly the same thing every single time. And very often, that's exactly what is required, right? Like if I create an invoice, I cannot have any variability in how the invoice is created, right? It's a set process. If I approve an invoice, that kind of thing. There's going to be aspects to a workflow where it's okay to have room. Like if I'm creative writing is one, right? For instance, where it's okay to have that probabilistic nature. But yeah, you make a good point. It's the odd intersection of probabilistic versus deterministic, right? Like pretty much everything that we do is deterministic, and we're now looking at things and where can we introduce some probabilistic nature without it hurting ourselves, right? So, but we have to be careful with that, absolutely, right? Because you can lose some of that predictability and without paying too much attention. And there's a question at the back there too.
Yeah. Sorry, just moving on from that. You spent quite a lot of time there saying how you build these models so it does exactly what you want it to do, and then how you get the information back and have it do exactly what you want to do. At that point, surely it's just well, that's a button then, isn't it, rather than actually going through AI. I can understand, if you are coming through AI, that's, you're asking the question there, but if you want to take a specific question and say, I want to see all of my open invoices, that's something you could just code directly into FileMaker, isn't it?
Absolutely, absolutely. Yeah, and I think that's exactly the question, and it's a follow-up to what we were discussing, right? Like it's, at some point, in that Gartner hype curve, right? Like it's so easy to look at AI and go like, oh, I'm going to try and solve this with AI, but if it's just a simple deterministic workflow, do you need AI, right? So that's the thing that you'll need to figure out. And I'm sure that we'll go overboard to some extent by throwing AI at things where really we don't need to. But those things will level out. But both of those points are very good to keep in mind. Like what's the level of probability that I want to have in this, right? And that answers that question.
Thank you for your presentation. I was curious if you create these scripts which are connected to the model, would the model start harvesting your solution to get some data source for itself which it can use for its work?
It's a good question, right? Because there could be some fear that it does that. Short answer is no, right? Because there's a level of abstraction between your solution and the AI application or the model by putting the MCP server in the middle, right? So the AI application only talks to the MCP server. The MCP server cannot give anything that you didn't define. So there's no harvesting of that. In more general terms, when I was talking about data privacy and intellectual property security, if you use some of the capabilities to say, have a model generate a SQL query based on your solution, you have no choice but to give the model the full structure of your solution, right? Otherwise, it wouldn't know what your table names are, or your field names are, or how they're related. So the model at that point, and whoever controls the model, where the model is hosted, will have the full schema of your solution. There's no other way around that, if you want to use that capability. Right? And hence the question is that if you think it's important, if you don't trust any of the providers with that level of information, then you'll have to look at self-hosting the models, which you can do, right? Where you host the model on your own server on premises, and then that data flows nowhere. So with MCP, the answer is no. In general, with AI, it's something to consider, right? Like, understand the features that you're using and what kind of data that it requires to flow to wherever the model lives is very important.
Wim, you mentioned the limits that you run into with the AI. How do you know when you're getting close to exceeding those limits and start getting rubbish back?
You use the logs in essence, right? Like every call that you make, every call that the AI application makes to the model server, because it's just JSON, but it includes information about the number of tokens used, input tokens and response tokens. So as you're developing, you'll keep an eye on that to go like, at what point does all of these tokens add up? You also know the length of your instructions. Like you can calculate the number of tokens that your instructions are. So there's a couple of different ways that you measure, but yes, it's a responsibility that as developers, we need to make sure that we measure and can figure that answer out.
So you spoke about MCP limits and how to, well manage the MCP to use the best context. What are the differences on performance and the limitation of MCP against API calls?
Oh, it's a good question. You're introducing an extra step by using an MCP server, right? So you can expect a little bit of delay because of that, because your AI application has to talk to MCP, the MCP has to talk to your API and the other step back. Whether it's important enough, whether that impacts your performance to the point that you now find it unacceptable, that really depends on the solution, right? The biggest slowdown is always going to be the data and OData API call to your FileMaker solution, right? Because that depends on wherever your FileMaker server is, depends on how your solution is built, the efficiency of your solution, that kind of thing. So I wouldn't expect that the introduction of MCP will add so much performance degradation that it would worry me. And I would still prefer using MCP versus making direct API calls from an AI application. Again, not being dogmatic about it. If I have full control over the API in application, I may consider making direct API calls and not doing MCP. One thing that I really didn't touch on, and I probably should have, is if you go to an MCP server, I can reuse that same connection in different AI applications and different places, right? And that's what I meant by tightly coupling. If I make an API set of connections from inside my AI application, it's more difficult to reuse that part than if I went to an MCP.
Or maybe if you have different models, the MCP can be set to call in different ways. The models, instead of having multiple API or multiple API.
Possibly, yeah, possibly. All right, that's it. Thank you very much.